The standard equation of ellipse is x minus h quantity square by a square plus y minus k quantity square by b square equals 1. So we utilize this standard equation when a is greater than b, where a and b are the lengths of semi-major axis and semi-minor axis. Let me show the a and b in this diagram. So this length is basically a and this distance is basically b. So how do we calculate this a and b? Remember that we can use the distance formula to calculate the a and b. So if this distance is a, this distance is also a, and similarly this distance is also b. So we know that the distance, that is starting from this vertex negative 6 comma 4 to 10 comma 4 is basically 2a. So first let's calculate 2a. This 2a is equal to distance between the points negative 6 comma 4 and 10 comma 4. We can simply find the difference, that is 10 minus of minus 6, this absolute value equals 10 plus 6 is 16. So 2a equals 16, which means a equals 8, and similarly 2b equals, we have to find the distance between the points 2 comma 9 and 2 comma minus 1. So we find the absolute difference between 9 and minus 1, which is 9 minus of minus 1, and this is equal to 9 plus 1 is 10. So 2b equals 10, which means b equal to 5. So now we know the value of a and b. So we can substitute into this equation. But let's find the center h comma k. The coordinate of the center is h comma k. Basically, the center is halfway between the co-vertices and vertices. So we can apply the midpoint formula either to the vertices or to the co-vertices. So let's consider the vertices 10 comma 4 and negative 6 comma 4. Let's apply the midpoint formula for this to find the coordinate of h comma k. So this will be 10 minus 6 by 2 comma 4 plus 4 divided by 2. This is basically h comma k. So this gives 10 minus 6 is 4. 4 divided by 2 is 2. And 4 plus 4 is 8. 8 divided by 2 is 4. So basically this is h comma k, which is nothing but the center. Now we substitute a equal to 8, b equal to 5, and h equal to 2, k equal to 4 into the standard equation of the ellipse. So therefore we will get x minus h quantity square, that is x minus 2 quantity square by a square. A is 8, so a square equal to 64 plus y minus k, which is y minus 4 quantity square divided by b square. B is 5, so b square equal to 25 equals 1. So this is the standard equation of the ellipse for the given vertices and co-vertices. We now determine the foci. So for this, let me put the diagram one more time. Okay. So the foci is basically, if we consider this as the center, is basically a point on the semi-major axis. So there are two foci. Let's consider the C1 and C2 are the foci, and this is the center of the ellipse. So it is at a distance of c units and c units from here. So therefore, we have to calculate the foci using the formula c square equals a square minus of b square. So we know the value of a square, which is given over here, that is 64, and this is b square. We can substitute here. Therefore, 64 minus of 25, this is 39. This implies c equals square root of 39. and let me mark the center. The center is 2 comma 4. So therefore this coordinate is 2 comma 4, and this means it is at a distance of root 39 from 2. So we can say that the coordinate of the C1 is basically equivalent to 2 plus root 39 comma 4. And similarly, the coordinate of this another foci is 2 minus root 39 comma 4. This is another foci C2. So these are the coordinates of foci, and this is the standard equation of the ellipse.